All right, guys, I'm going to do a few select problems on the review, like a sampling of one of each type of problem for the Unit 8 test coming up soon. So the first problem I'm going to work is number 1 here. We're trying to find the definite integral, which if you have a calculator, you can put this into your calculator. If you don't have a calculator, you need to find the integral of this and then plug in the values and subtract them. So first, because I have a square root here, I'm going to use my u substitution to make it a little bit easier. Whenever you have a function inside of a function, it's kind of helpful to do u because we can't do chain rule, product rule, or quotient rule. So for the u, I'm going to choose the inside of here, which is 4 minus x. Then I'm going to take the derivative of that. The derivative of 4 is just 0. The derivative of negative x is negative 1. So I want to substitute this in for dx, so I'm going to rearrange it so that dx is isolated. So that's the same thing as du divided by negative 1, which is also just negative du. Okay, so now I'm going to rewrite this in u format. So we're going to translate everything into the land of u. So if I want to translate this 3 into the land of u, I need to plug it in terms of u. So 4 minus 3 is 1. And then I want to translate this. 4 minus 4 is 0. The square root can be written as to the power of 1/2. So I'm going to rewrite this as u to the 1/2 power. And instead of dx, I'm going to plug in my negative du here. I don't want that to look like a minus, though. So du, and it's really going to become a multiplier outside. Remember, you have a number there. So I'm going to leave it like that. I'm going to leave it outside. Okay, now I'm ready to find the integral of this. So remember, to find the integral is we raise the exponent by 1. So that's going to be u to the 3/2 power. And then I divide by that new exponent. So if I divide by 3/2, that's the same thing as multiplying by 2/3. And I want to evaluate that at 0 and 1. All right, so now that we have the integral, we're going to plug in 0, and we're going to plug in 1, and we're going to subtract those values to find our solution here. So if I plug in 0 here, 0 raised to the 3/2 power is still 0, and 0 times that is still 0. So I'm not going to put negative 0. I'm just going to put 0 minus. Okay, now I'm going to plug in the 1 here. So when I plug in 1, this means take the square root of 1, which is still 1. 1 cubed is still 1. And then 1 times this negative 2/3 is negative 2/3. All right. So then when 0 minus a negative 2/3 should just be positive 2/3. Okay, so in this example, we did a definite integral where we had endpoints. I'm going to skip to number 5 here. Notice this is going to be an indefinite integral. We do not have endpoints. So all we have to do is integrate it, and then be sure to add plus c at the end of whenever we have an indefinite integral. Before I integrate this, I would like to simplify this. I don't need u substitution if I'm able to simplify this. I can divide x squared into each term to make it a little bit easier to do our integration step. So I'm going to rewrite this. 5x squared divided by x squared is just 5. And then I'm going to do negative 2x divided by x squared. Now that would be 2 over x. I do not want to write this as x to the negative 1 because when I integrate that and raise the exponent by 1, that'll be 0. Remember that it's better this is going to be our natural log. Okay, so whenever this is the one exception to making a negative exponent. Instead of making a negative exponent, we're going to keep it in this format because this is going to be our natural log. This one, however, I'm just going to put x to the negative 2. dx. Okay, we are ready to integrate now. So to integrate, I'm going to raise the exponent by 1, so that'll be 5x. And when I divide by 1, still the same thing, minus. Okay, when I integrate this one is a special case. Natural log, oh, I forgot my 2. 2 is a multiplier. Natural log of x, the absolute value of x. So that's that piece. That's the integral of that. And then the last piece, I'm going to raise the exponent by 1. So that's -1. And then I'm going to divide by -1. So that's going to change this to a minus. And then I'm going to add my plus c. So this answer would be fine for free response. If it was on the multiple choice test, it probably will be rewritten with this as 1 over x to look a little cleaner. So, but these are equivalent expressions. Okay, so that's the difference between doing a definite integral, you'll get a value, versus an indefinite, you will have a new equation there when you're doing an indefinite integral. Okay, moving on down here. There's one of each of that section. In the bottom section here, I'm going to do 10 and 11 as a comparison here. The difference between these two, we're doing the integrals of a function. Notice that this one has a function and this just has an x. So I want to point out the differences here. We are trying to find the derivative of f, okay? When I find the derivative of an integral, they essentially cancel each other out. However, I do need to plug in, this just needs to be a constant. It doesn't matter what number this is. If it's a constant, we plug this in for our x's here. So how I'm going to write this is the derivative of f is 3x squared minus 3x. All I did is I plugged the 3x in for both of those t's. And if this was on the multiple choice, they probably would simplify this a little bit. So 3 squared is 9x squared minus, oops, I forgot one thing. This was what I wanted to show you the difference of. Hold on. I plugged in my function, but I also, whenever this is a function, I also have to multiply it times the derivative of that. So the derivative of this is just 3. Okay, now I'm ready to simplify. So this is 3 squared is 9 times this 3 is going to be 27x squared minus 9x when I distribute it there. So that's how that would look simplified. Now I want to show you the difference between this one. This is the same idea. I'm going to plug in x for my t's. So f prime of x, I'm going to plug in x squared times the square root of 1 plus x cubed. The derivative of x is just 1. So that's why when multiplying this by 1, it just doesn't change the function at all. So that's all you have to do for this. If you're taking the derivative of an integral, it cancels each other out. Your only job is to plug in that x right there. So don't forget, this is usually what's forgotten. When we're plugging in a function inside of a function, you got to make sure and multiply it times the derivative of what you're plugging in. That is the one thing to remember there. Okay, moving on. Number 13. I'm going to do a couple of these. We're starting here with a graph. And this is always key. We want to make sure and keep in mind that it's going to ask me a lot about g prime when I'm translating this graph. G prime, we should always translate, when I take the derivative of this, I'm just left with f of x, which is kind of like what we were just talking about there. But you always want to write that translation at the top because it's going to help you think through a lot of questions. So the first question is just g of -1. Well, g of -1, here's my g formula. So all I have to do is plug in to this exact formula. And what this is asking me to find is this is asking me to find the area under the curve between -1 and 0. Now notice it's flip-flopped, right? Like we should always have the smaller one on the bottom. So to fix that problem, I just put a negative out front. So I'm finding the area of the curve from -1 to 0 between there and there. So let's look at our graph to be able to figure that out. Between -1 and 0, well, that's just the area of a triangle. So base is 1 times 3 divided by 2 is 3/2. So the area of this is 3/2 of that little triangle right there. So this part is 3/2, and then I don't want to forget that negative right there. So -3/2 is the value of g of -1. Okay, g prime of -1, I'm going to think g prime is the same as finding f of -1. So all I have to do, because I'm looking at the F graph here, is to find -1. And what is the value at -1? Well, it's just 0. All right, now the last question is, what is G double prime of -1? So this is the same thing as asking, what is F prime of -1? So what is the slope at -1 is what it's asking. So my slope here, it's going up 3/1. It's just a slope of +3. Okay, skip down to D. Find the x-coordinate of each point of inflection on the graph of G. Remember when we're talking about G here, we have the G prime graph here. So we're keeping in mind that we're translating it here on this interval and justify your answer. So when we're talking about points of inflection here, when we're looking at the slopes graph, we're looking for where it's changing from increasing to decreasing. Where is the graph changing? So we're talking about the highs, the very highs and the very lows when we're looking at our graph here. So we only have one value that it's changing from increasing to decreasing, and that's when x is 0. So we would just say the point of inflection is at x equals 0 because the graph changes. I should be specific. The G prime of x graph changes from increasing to decreasing. Okay, part E. This is the one we've practiced a lot, but I want to make sure we have it down. The absolute max value. So what we're looking for is we always include the endpoints when it's absolute. So 0 and 2 are endpoints. And then when we look at the graph, we also want to find a potential max could be, remember these are all the slopes. So here my slope is changing from a negative slope to a positive slope at this point. And here it's changing from a positive slope to a negative slope. So this is a potential max. This is a potential min. So 1 is my other candidate that I'm going to test out. You get 1 point for choosing the right points to test. So at least get that part where you're thinking, okay, what are the candidates for being my maximum? Then to find your maximum values, we are going to use the equation that they gave us at the beginning up here. Okay, so the formula that we're going to use is to find between 0 and x of f of t d of t. So the first one is between 0 and 0. Well, that's just going to be 0 because there's nothing in between there, no value there. Now we're going to plug in 1, so from 0 to 1, f of t d of t. So all I need to know is what is the area under the curve between 0 and 1. Okay, 0 and 1. We already calculated that because if this is 3/2, then this also is going to be 3/2. So that value is 3/2. Now let's test 2. So that is testing between 0 and 2, f of t d of t. So between 0 and 2, so what I have here is 3/2. This is going to be -3/2, so those are going to cancel each other out. So that's actually going to be 0. So to answer the question, what is the absolute max? The absolute max is going to be 3. Absolute max value of 3/2 at the location of x equals 1. Okay, last question on this page. This little thing we need to kind of translate and see what it's asking. I usually think about there's kind of 2 pieces here, one piece here and one piece here. So if I rewrote this, p of x represents from -2 to x, f of t d of t plus -2 to x, 1 times d of t. Okay, so really there's 2 pieces I'm evaluating here. I would like to find p of 2. So that means I'm finding between -2 and 2 and -2 and 2 here. And what this means here is I'm doing 1 times however wide this is. Well, this is 4 units wide, between -2 and